You ready? What are we doing? We're simplifying trigonometric expressions. Yeah, and we're using identities all day, every day. Here we go. All right, we want to evaluate exactly. It smells like exactly? Is that what it is? No, I don't know. What is it? Okay, all right, now I'm here. Oh boy. What do I even do? I don't even know. Well, this inverse is going to get you two different triangles now. The sine is the opposite over the hypotenuse. That's why I've labeled the opposite over the hypotenuse. Now, looks like they have given you a wonderful Pythagorean identity. What's that say? That says that x squared plus 12 squared is 13 squared. Now, when you get all that, you find out that your x is 5, because it's a freaking triplet. Oh, hi, Penelope. Did you want to come up and say hi? Anyway, that's a 5. Now, this is a 3, 4, 5 Pythagorean triplet. Same thing. This is 3 squared plus 4 squared is, I don't know, hypotenuse squared, and that's how we get that. But where did we get that? That was the tangent inverse was the opposite over the adjacent, opposite over adjacent. Wait, now what do we need to really get in here? Oh boy, the sign of the difference. Oh boy, that's the sign of the difference. Okay, so this is my alpha and that's my beta. That being said, I have the sine of alpha. What's my alpha? The alpha is the sine inverse of 12 thirteenths, and then I subtract off, that's nuh-uh, because I'm using this form. That was the sine of alpha. That's your alpha. Then we multiply it by the cosine of beta. The cosine of beta. What's my beta? Looks like my beta gonna be the tangent inverse of 3/4. Sure. Now, that looks like that is gonna be way over there, because now I need to subtract off the sine of beta. Our beta is the tangent inverse of 3/4, and then I'm gonna multiply it by the cosine of my alpha. The cosine of my alpha. So the cosine of my alpha is the sine inverse of 12 divided by 13. Now, don't mind that. That's next by the flower palms. Anyways, over here. Yeah, everything looks good. Now, what does this say? This tells you which triangle you're using. That says use this triangle and read. Can you read? Yeah, you can read. Read off that triangle the sine. The sine off of that triangle is the opposite over the hypotenuse. So that's going to be 12 thirteenths. All right. So now it's the cosine of which triangle? Is it this triangle or is it that triangle? It's the tangent triangle. So without going off a tangent, I read the cosine off of this. The cosine is the adjacent over the hypotenuse, so that's a 4 over a 5 because it's the adjacent and the hypotenuse. All right, then I'm subtracting off. Now this piece was that, and then this piece was that. Now I subtract off the sine of the tangent. The tangent triangles this. The sine off of that, that's the opposite over the hypotenuse. Sure, that's that 3 over that 5. And then I'm going to multiply it by the cosine of which triangle am I using? Which triangle am I using? Am I using the sine triangle or the tangent triangle? I'm going to call that alpha and beta. Yeah, because that was my beta. Oh, okay, fine. So I'm looking for the cosine off the sine triangle. The cosine is the 5 over the 13. That's that 5 over that 13. All right, so then fractions happen, and no way. Box and flower. Wait, can I cancel the 6s and can I cancel the 5s? Oh, let's get another one. Now it's kind of the same thing, but we're using a different trigonometric identity. So let's get ready to trig. Hold on. Let it buffer. Bruce, Let's go. All right. So then the tangent of, I'm going to call that my alpha. I'm going to call that my beta. So this is my alpha triangle. That's going to be 5 again. This is my beta triangle. That's going to be 5 again. I got 5 on it. It's all right. So we're looking for the tangent of the sum. So that's going to be the tangent of, now wait for it, alpha. That's the cosine inverse of 12/13. All right, and then we're gonna add to it the tangent of the tangent triangle. That's the tangent inverse of 3/4. Wait, what are you doing? I'm using a trigonometric identity and a right triangle to evaluate the sum of the trigonometric function of the sum. So then I go down and I look at, that's minus the tangent of my alpha, which was the cosine inverse of 12/13, and we're going to multiply by the tangent of my beta, which was the tangent inverse of 3/4. Now, can you read? That's not fair. Okay, so the tangent of the cosine triangle, if we read the tangent, that's a 5/12. That's a 5/12 because it's the opposite over the adjacent, the tangent of the cosine triangle. All right, and then the tangent of the tangent triangle, well, isn't that just the argument? It sure is. So then we're going to add to it, because of the addition, we're doing this piece. We add to it the 3/4, because the tangent off the triangle tangent's the 3/4. Now what? Now I'm down here, and that's minus, wait, the tangent off the cosine triangle, that's this alpha. The tangent is the 5/12, sure. Tangent of the cosine, that's the 5/12. All right, so that's a 5/12, and then I'm going to multiply it by the tangent of the inverse tangent of 3/4. That's the argument itself. Let's have 3/4 for sure. Then it's a little fraction action, and I go and I put it in there. So then, oh boy, we have a little small answer. It's like Pee-wee. Oh, 45. And then what? Sure. But that ship sailed.